Let's look at some true and false questions and problems from chapter 7. Starting with the true and false questions. A population mean is an example of a statistic. This is false. If it comes from a population, then it's a parameter. So it is false. Sampling error is the difference between a sample statistic and a population parameter. That is true. We have x bar minus mu. Number 3, a small sample size could provide a smaller sampling error than a larger sample size when taken from the same population. This is correct. This is true. To use the central limit theorem, we need to know the mean and standard deviation of the population. This is false. We need to know also the sample size, n. 5, the higher the standard error of the mean, the less variation you will notice from one sample mean to the next as they are drawn from the population. False. As the sample size increases, the interval that contains 95% of the sample means becomes narrower. That is correct. When the proportion of sample size of population size n is greater than 5%, the finite population correction factor is used to adjust the standard error of the proportion. This is correct. So this is true. A what sample is a sample in which every member of the population has an equal chance of being chosen. This would be a simple random sample. In a what sampling, we divide the population into mutually exclusive groups and randomly sample from each of these groups. This would be the stratified sampling. Dean has been hired to visit the local shopping mall to conduct a survey about the upcoming political elections. She needs to select respondents at the mall and ask them questions about their voting tendencies. Dean decides to walk around the mall and select shoppers to participate. Which of the following sampling technique best describes Dean's method? This would be a convenience. The central limit theorem states that the sample means of large size samples will be normally distributed regardless of the shape of their population distribution as long as n is greater or equal to 30. Clearbags is an online company that sells packaging materials for photographers. Suppose their average order size is $208.19 with a standard deviation of $53.44. A random sample of 35 customers' orders have been selected. The standard error of the mean for this sample would be what? Standard error of the mean, sigma x bar is equal to sigma over square root of n. Sigma is 53.44. Sample size is 35. We take the square root of that. This would be equal to 9.03. So the correct answer will be C. An Epson inkjet printer advertises that the blank ink cartridge will provide enough ink for an average of 245 pages. Assume that this claim is accurate and that the standard deviation of this population is 15 pages. A random sample of 33 customers was surveyed about the number of pages they were able to print with their blank ink cartridges. What is the probability that the sample mean will be 246 pages or less? So I'm looking for the probability of x bar to be less than or equal to 246. Normal distribution. We have mu x bar is 245. 246 is to the right. Less than or equal, I'm looking for this whole area. We calculate the z-score. The z-score will be equal to 246 minus 245 over 15 divided by square root of 33. Your sample size is 33. You want to make sure you use parentheses when you do your calculations. This will be equal to 0.383. You will take 0.38. This will give you 0.148. So this area here will be 0.148. So to find this area, we will do 0.5 plus 0.148. So the probability will be 0.648. 0.648. The correct answer will be A. Suppose the average driving distance for last year's Masters Golf Tournament was 282.5 yards with a standard deviation of 12.2. A random sample of 30 drives was selected from a total of 4,144 drives that were hit during the tournament. What is the probability that the sample average was 279 yards or less? So I'm looking for the probability of x bar to be less than or equal to 279. New x bar is 282.5. 279 is to the left of the mean. Less than that, I'm looking for a left tail. Z-score 279 minus 282.5 over 12.2 divided by square root of 30. So this will give us a negative 1.57. We look up the absolute value from our table of 1.57. 1.57 will give us a probability of 0.4418. Since I'm looking for a tail, 0.5 minus 0.4418, and this will give me 0.0582. Now, the average age of cars and light trucks in the US is 10.8 years. Assume that the standard deviation for this population is 3.7. A sample of 35 randomly selected vehicles was selected. What is the probability that the sample mean will be greater than 10? So I'm looking for the probability of x bar to be greater than 10. We draw the normal curve. New x bar is equal to 10.8. 10 is to the left, greater than 10. I'm looking for the whole area to the right of 10. Calculate the z-score. 10 minus 10.8 over 3.7 divided by square root of 35. Make sure you use your parentheses once again. Negative 1.279. You round up to negative 1.28. We need to round up to 2 decimals because our table goes up to 2 decimals. This will give me a probability of 0.3997. This part is 0.5, so we simply add these two, and the answer will be 0.8997. So the correct answer will be C. Let's look at the problems. According to the National Retail Federation, men spend an average of $484 over a recent Black Friday weekend. Assume that the standard deviation for this population is 146. A random sample of 42 men shoppers over this weekend was selected. What is the probability that the average amount spent on Black Friday weekend from this sample was less than $500? So I'm looking for the probability of x bar to be less than 500. We have mu equal to 484. We have sigma equal to 146. We have n equal to 42. And basically, this is the information given to you. This is the probability you're looking for. We calculate the mu x bar is 484. 500 is to the right of the mean, greater than the mean. I'm looking for x bar to be less than. That means I'm looking for the whole area to the left. We calculate the z-score. Z-score is 500 minus 484 over 146 divided by square root of 42. This will be equal to 0.7102. So we look up for 0.71. We round up to 2 decimals. 0.71 will give me a probability of 0.2611. This area is 0.5. So to find the probability of X bar to be less than 500, I will do 0.5 plus 0.2611, and this will be equal to 0.7611 for the probability. Now, according to the National Retail Federation, women spend on average $317 over a recent Black Friday weekend. Assume that the standard deviation for this population is $90. A random sample of 50 women shoppers over this weekend was selected. What is the probability that the average amount spent on Black Friday weekend from this sample was more than $300? So we have mu 317, sigma we have 90, n is equal to 50. I am looking for the probability of X bar to be greater than 300. We calculate the z-score. X bar is equal to 300 minus 317 over sigma, which is 90, divided by square root of 50. If you do your calculations, this is going to be negative 1.334. Actually, it's 6. We have to round up to 2 decimals. So the z-score will be equal to negative 1.34. This is what you're going to look up in your table. So you take the absolute value, 1.34 will give you a probability of 0.4099. This area, once again, is 0.5. So all you need to do is add the 2, 0.4099 plus 0.5, 0.9099 for your probability. Now, for the next one. According to Nielsen, the average smartphone owned used 606 megabytes of data per month. Assume that the standard deviation of data usage was 240 megabytes per month. A random sample of 60 smartphone users was selected. What is the probability that the average amount of data used in the sample was less than 580? This is the probability I'm looking for. The mean is 606. The standard deviation is 240. Sample size is 60. So this is the area that I'm looking for. Mu X bar is the same as mu, 606. 580 is to the left, less than 580, then I'm looking for a left tail. We calculate the z-score. The z-score will be equal to 580 minus 606 over 240 divided by square root of 60. Again, we use our parentheses. This will give me negative 0.839. We will round this up to negative 0.84, which will give us, if you look up the z-score 0.84, will give you a probability of 0.2995. Since I'm looking for a tail, I will subtract from 0.5. 0.5 minus 0.2995, and this will be equal to 0.2005. So the probability of X bar to be less than 580 is 0.2005. According to a recent Catalyst census, 16% of executive officers were women. Were women with companies that have company headquarters in the Midwest. A random sample of 125 executive officers from these companies was selected. What is the probability that more than 20% of this sample is comprised of female employees? The assumptions are satisfied since n times p, 125 times 0.6 is equal to 20, which is greater or equal to 5. N times 1 minus p, 125 times 1 minus 0.16 is equal to 105, which is also greater or equal to 5. The proportion is 0.16. The sample size is 125. And we want to calculate the probability that p bar is greater than 0.2. So we have p.16. We want to find the probability that p bar will be greater than 0.2. So I'm looking for a right tail. We calculate the z-score. This will be 0.2 minus 0.16 over square root of 0.16 times 1 minus 0.16 over 125. If you do your calculations, this will be 1.22. Now, we check for the probability for 1.22. So we will have a point, this area here will be 0.3888. We are looking for a tail, so 0.5 minus 0.3888, and this is going to be equal to 0.1112. For the next problem, a recent survey found that 86% of employees plan to devote at least some work time to follow games during the NCAA men's basketball tournament. A random sample of 100 employees was selected. What is the probability that less than 80% of this sample will devote work time to follow games? The assumptions are satisfied since n times p, which becomes 86, is greater than 5. N times 1 minus p, 100 times 1 minus 0.86, which is 14, is also greater than 5. The proportion is 0.86. The sample size is 100. And we want to calculate the probability that p bar is less than 0.8, less than 80%, less than 0.8. So we have p.86, p bar, we have 0.8, less than, I'm looking for a left tail. We calculate the z-score. So 0.8 minus 0.86 over square root of 0.86 times 1 minus 0.86 over 100. This is going to be equal to negative 1.729. You're going to look up z-score of negative 1.73. We round up to 2 decimals. So 1.73 will give you a probability of 0.4582. Since you're looking for a tail, 0.5 minus 0.4582. And this will give you a probability of 0.0418. Now, for problem number 6, a recent survey found that 42% of IT professionals monitor employees during trying to access videos of NCAA men's basketball tournament. A random sample of 75 IT professionals was selected. What is the probability that between 40% and 48% of this sample will monitor employees trying to access a video of the NCAA men's basketball tournament? So, first off, we start with the assumptions. The assumptions are satisfied, n times p and n times 1 minus p. The proportion is 0.42. If you look at our graph, this is 0.42. We are looking for the area between 0.4 and 4.48, 40% and 48%. We have two values. We will need to calculate two z-scores. So for the first z-score, we will do 0.4 minus 0.42 over square root of 0.42 times 1 minus 0.42 divided by 75, which is your sample size. This will be negative 0.351. Z2, we're going to do 0.48 minus 0.42 over square root of 0.42 times 1 minus 0.42 over 75, and this is going to be 1.053. So we will look up z-score for negative 0.35. We're going to take the absolute value, and z2 will be 1.05. So this area for 0.35 will be 0.1368, and for 1.05 will be 0.3531. Since the mean is inside the area we're looking for, we will be adding the corresponding probabilities. So 0.1368 plus 0.3531, this will be equal to 0.4899. And this completes the problems for chapter 7.